Okay, so we're going to be talking about lesson 7.6, factoring ax squared plus bx plus c. And we're going to learn to factor that into two binomials. So learning targets, factor ax squared plus bx plus c and use that to solve real life problems. So a couple ways you can approach this. There's no new vocabulary here, but the couple ways that you can approach this is you can simplify the problem before you even get started. So for example, if you have 5x squared plus 15x plus 10, notice that they're each divisible by 5. So if I take a second and I pull that 5 out, what do I have left? Well, I have an x squared. 5 goes into 15x, 3x, and 5 goes into 10, 2. And I can just factor now what's between the parentheses here. So 2 and 3. What number multiplies to 2 but adds to 3? That would be 1 and 2. 1 plus 2 is 3. 1 times 2 is 2. So this is still your multiply and your add. And when you're writing this out, don't forget your original 5. And you're done. Try it again. You have 4, and 4 goes into 32, and 4 goes into 60. So before you get going on a problem, see if you can have this number right here, what we would refer to as the A, in a standard form. See if you can have that go into one of these numbers. So if you can, or both of these numbers actually. So if you can, you're good to go. So pull it out. When you pull out a 4, you have x squared left over. 4 goes into 32 8 times. And 4 goes into 60 15 times. And voila. So you're going to have 15 and 8, two numbers that multiply to equal 15, but when you add them equal 8 are 5 and 3, or 3 and 5, it doesn't matter. These are interchangeable. So 4x plus 5x plus 3. And you're good to go. Just don't forget to bring that 4 with it. Now, what happens when it's not that easy? You can't put 4 into 13 evenly, or 3 for that matter. It would be kind of a hot mess if you tried. So what do we do in those situations? Well, we still multiply here, but we're going to multiply the 4 and the 3, and we're going to get 12. And then we're going to bring down our 13 from the middle. So I'm looking for two numbers that multiply to equal 12, but add to equal 13. That would be 1 and 12. Notice I wrote them kind of smaller and towards the top, because I'm going to take another step here, and I'm going to show you the step in more detail down here. But I'm going to take another step here, and I'm going to divide this by the 4, and divide this by the 4. I'm going to take a second to reduce this. And even though I already know this is reduced, I always like to rewrite it so that I'm not missing that step. And then 4 goes into 12 3 times. So I write the 3. Now, leave it. Leave it alone. I know that this is 3, but leave it as 3 over 1. Because what you're going to do here is you're going to put an x with this, and you're going to put an x with this. So when you factor this now, it's going to be 4x plus 1 and x plus 3. I don't need to write the 1 here. So it's just x plus 3. So x plus 3, 4x plus 1. And you just factored this equation, polynomial, binomial, quadratic. You just factored all of that. Awesome. Try it again. So 3 times 2 is 6, and you have a negative 7 here. So two numbers that multiply, negative 6, negative 1. Again, notice how I left myself some space here, because I still need to write under here the 3's. And I'm going to go ahead and reduce. And I'm going to go ahead and, even though I know it's already in reduced form, put that off to the side. I'm going to add my x's here so that I know that's where I'm doing that from. Eventually you won't have to do that because you'll just know that's where it comes from. But you have x minus 2 from right here, x minus 2, and 3x minus 1. Now, if you're concerned about this at all, go ahead and multiply that back out and check your work. So what are we doing here? We are actually taking the a and the c, and we're multiplying those right here. And then we're taking the b, and we're putting it right here. So no matter how you do that, this could be a plus or a minus. In this case, it would be a minus. But no matter how you carry the sign with it, but no matter how you do that, these are where you get your numbers from. When you get the two numbers here and here, go back and divide it by that number in the front, the leading coefficient, a. That's going to go here once you reduce it, and that's going to go here once you reduce it. And then this will be a number, and this will be a number. Number 1, number 2. So number 1, number 2. Basically, it's about that easy. So let me actually show you again now that I've explained that, and do a few more examples. So I have -7 times 2. By the way, you'll eventually not have to write this either. It's just one of those things when you're learning, kind of helpful. So -14, -5. Two numbers that multiply to equal -14 but add to equal -5 are -7 and 2. Again, leave yourself some space there. So you can divide this by 2. Now we all know that 2 over 2 is 1, but in this case you're reducing to 1 over 1, and then you're just going to leave it alone. And here, this is already technically in what you would consider reduced form for this type of problem. So I'm just going to rewrite it, just so that I can. Remember, this is where your x's are. So when you factor this, it's going to be 2x minus 7 times x plus 1. I almost said minus, but it's plus. Try it again. So -4 times 5, -20. So you're multiplying these two together. You're bringing down your b. And the two numbers that multiply to equal are going to be 2 and -10. Okay, they multiply to equal -20. They add up to equal -8. So divide that by your number here. Include the negative. So -4, -4. Reduce and reduce. So this is going to become positive. 5 halves. And then your answer becomes -2x plus 1 and 2x plus 5. Voila. Okay, let's try it again. The more you see this, sometimes it helps. Okay, so I'm noticing something right off the bat here, and I'm hoping you're noticing it too. So you see this 8 right here? Well, I know that it goes into 56 and 48. So I'm just going to do a little quick pull it out, and I'm left with x squared minus 7x plus 6. So the problem became just slightly less complicated for you. So you have 6, -7. So two numbers that multiply for that is -1, -6, and you get 8 times x minus 6, x minus 1. So don't be fooled just because you might have something in front here. Don't forget you can use the greatest common factor and pull that number out of there. But then take a look at this one. It's got a big old 14 here. Kind of crazy, kind of big. Well, this 14 right here, 14 and 15, that multiplies to equal 210. And the 31 goes down here. So two numbers that multiply to equal 210, but add to equal 31, or 21 and 10. And then divide those by the 14. Don't forget that step. That's actually beyond important. So when you reduce this, you get 3 halves and 2 sevenths. Okay, so remember, this is where your x's go, on the bottom. Like I said, eventually you won't even need to write that. You'll just have it down. So this is 2x plus 3 and 7x plus 2. By the way, this method isn't mine, but it's brilliant. And whoever came up with this, it's amazing. So what I suggest you do now is take a look at these examples. Just take a couple minutes, pause the video, take a look at these examples, make sure you have these patterns down, and then we're going to try it on the back side. So this is where I want you to try a couple, just to make sure you've got this. So pause the video for a second, see if you have this. If you do, fantastic. If you need more help, I'll be going through these, but I'll be going through them quickly. Pause the video in 3, 2, 1. Welcome back. So numbers here, 2 times 5 is 10. Multiply, add, -7. Those numbers would be -2, -5. Divide by your first number that's right here, the 2. Divide by the 2. Reduce. So you get -5 halves because you can't really reduce that. And then you get -1 over 1. Notice that I'm leaving the negative where it was. I'm not pulling it down or pulling it to the side. So your answer here is x minus 1, 2x minus 5. On this one, you're going to have 24, -14. So that would be -12, -2. Divide by 3. Oops. So it's -2 thirds and -4 over 1. So that looks like 3x minus 2 and x minus 4. Hopefully you got those right and you've tried them ahead of me. Last two here. So you're going to have -20, -19, 1/4, -20 over 4, -5 over 1, 1/4, 4x plus 1, x minus 5. Last one. You're going to have -72, 1, 9, -8, 6, 6, and 3 halves, -4 thirds, 2x plus 3, 3x minus 4. So take a second, pause the video if you need to, check your work. Let's solve some real life problems. I have about less than a minute left on this video. So the length of the rectangular game reserve is 1 mile longer than twice the width. So this is what the equation looks like. The area of the reserve is 55 square miles. What is the width of the reserve? So 2w squared plus w minus 55 equals 0. Remember, when we do this, we have to equal 0. So I distributed the w and subtracted the 55 to get this equation. So I get -110, 1, 11, 10, 2, 2. Sorry, I'm not explaining this. I am running out of time. 5, 1. So what do I get? X minus 5 and 2x plus 11 equals 0. So x minus 5 equals 0. 2x plus 11 equals 0. And you can solve this and get x equals 5, x equals -11 halves. So if you plug this back in, 5 times 2 times 5 plus 1 equals 55. That is correct. So that is our answer. and W equals 5 miles. Okay, I'm not going to have time to do the last one because my recording will probably cut out here in a second, but I'm going to put the answer up here so that you can see it and at least have a visual. So the visual of that last answer. And if you have any questions, as always, please feel free to try to get into contact with me. I will be more than happy to assist you with some problems and any questions you might have about the process of doing this. Take care.